All right, let's talk about something that makes our entire digital world work, but that you probably never, ever think about. It's this invisible, super meticulous engine that makes sure everything from your emails to your online shopping arrives perfectly. We're talking about TCP, the real unsung hero of the internet. So let's pull back the curtain and see exactly how this thing works.
I mean, really, stop and think about that for a second. You click download on some massive file. We're talking gigabytes of data, and it just works. Every single bit arrives perfectly. How on earth is that possible when the internet itself is this huge, chaotic, messy place? Well, that's the million-dollar question we're going to answer today.
You know, to really appreciate our hero, TCP, we first have to understand the villain of the story, or at least the problem it solves. The internet's most basic delivery system is something called the Internet Protocol, or IP. And IP all by itself is basically the Wild West. It's designed to be fast, but it makes absolutely no promises.
Yeah, so IP operates on what's called a best effort basis. The best way to think about it is like a postal worker who just kind of chucks your postcards in the general direction of your house. As you can see here, some might get there, some might get lost, and they'll almost certainly arrive in a completely random order. And for the important stuff we do online, best effort is, well, it's not good enough. We need guarantees.
So what this means is that IP on its own doesn't promise your data will show up at all, it doesn't promise it'll be in the right order, and it certainly doesn't promise that it won't get messed up along the way. Your little packets of data can just hit a busy router and poof, they're gone. This is exactly why we need another layer on top of this chaos. And this is where our hero, TCP, steps onto the scene. TCP stands for Transmission Control Protocol, and it's like the super organized, reliable manager that comes in to clean up IP's mess. It's the solution that gives us the guaranteed delivery we absolutely depend on.
So TCP is basically a set of rules that builds a reliable service on top of that unreliable IP foundation. And look at those key words right there: reliable, ordered, and error-checked. It takes the whole, maybe I'll get there attitude of IP and turns it into an it will absolutely 100% get there, and it will be perfect.
Just for a little bit of technical context, if you think of the internet as a stack of layers, TCP works at what we call the transport layer. You don't need to memorize that, but its job, essentially, is to manage the entire conversation between your app, like your web browser, and the server on the other end.
So how does it all begin? Well, TCP is polite. It doesn't just start shouting data into the void. First, it establishes a solid connection. The best analogy is making a phone call, right? You don't just start talking. You dial, you wait for them to pick up, and you both say, hello, to confirm you can hear each other. TCP does pretty much the exact same thing with what's called the three-way handshake.
It's this really simple three-step conversation. First, your computer sends out a little packet called a SYN, which is basically it saying, hey server, are you there? I'd like to sync up. The server, if it's listening, replies with a SYN-ACK, which says, yep, I'm here, I acknowledge your request, and I'm ready to sync too. Finally, your computer sends one last ACK back, which just means awesome, we're connected, here comes the data. And that's it, the connection is solid.
Okay, so the line is open. The handshake is done. Now the real magic of TCP begins. I want you to imagine you have to send a 1,000-page book to a friend. You wouldn't just stuff it all in one giant box and hope for the best. No. You'd number every single page, and you'd want a receipt confirming they got it. Well, TCP does exactly that with your data. So first, TCP chops your data up into smaller, numbered chunks called segments. And this is the secret sauce right here. Every single one of those segments gets a unique sequence number. This is so important, because even if the packets get all scrambled and arrive out of order, which they will, the computer on the other end knows the exact order to put them back together. It's just like restacking the pages of that book. Now, how does the sender know the pages actually arrived? For every chunk of data the receiver gets, it sends back an acknowledgment, an ACK. This is the receipt. It's literally the receiver saying, okay, got it. I have everything up to page 100. You can send page 101 now. This constant back and forth, this feedback loop, is what makes the whole thing so incredibly reliable. But come on, this is the internet. Things go wrong. Packets get dropped, they just vanish into the ether. So what happens if one of the pages from our book goes missing, or what if the receipt saying it arrived gets lost on the way back?
This is TCP's beautiful, elegant safety net. Every time the sender sends a packet, it starts a tiny little countdown timer. If that timer runs out before it gets the receipt, the ACK, it doesn't actually know why. Was the packet lost? Was the receipt lost? It doesn't care. It just assumes the worst and sends that packet again. It's that simple. No data ever gets left behind.
So we've gone through the handshake, the page numbers, the receipts, the resends, but why does any of this technical stuff actually matter to you? Well, because this obsessive, careful process is running silently in the background of almost everything you do online.
Every single time you download a big file and it just works, that's TCP. Every time you load a complicated website and all the pictures and text are in the right spot, that's TCP. When your email shows up perfectly, or when you make a bank transfer and you trust that it went through correctly, you have TCP's obsession with reliability to thank for that.
This quote really just nails it. The ultimate promise of TCP is that the stream of data your app gets is a perfect, identical copy of what was sent. No mistakes, no missing parts, no duplicates, and everything in the exact right order. It basically creates trust on top of a network that is fundamentally untrustworthy.
So what this all comes down to is a trade-off. TCP gives up a tiny bit of speed in exchange for absolute rock-solid reliability. And for most things, that's a fantastic deal. But it does leave us with a really interesting question. What if you didn't need that perfect guarantee? What if for something like a live video stream or an online game, what you really cared about was pure, raw speed, even if a few packets got dropped? Well, that is a story for another time. Thanks for watching.